Hello, my name is Matthew Murphy, and this is my project, The Development of Gesture-Controlled Technology by Means of Bend-Sensing Carbonic Insulation. Now, for the introduction. Flex sensors, or flexible potentiometers, detect change in resistance when bent. The cost of many sensors is a limiting factor because it can cost over $100 for one singular glove of sensors, assuming you're building a robotic hand that detects the motion of fingers. And reducing price and increasing accuracy allows for more complex technology. Some other relevant projects would be Lawrence Lie's DIY glove-controlled robotic hand, which was a similar concept to ours, but we worked out some of the issues that were originally present in that model. And then another one, robotic hand with wireless glove controlled NRFL 24L01 plus Arduino. And that has the normal type of flex sensor. Now, our engineering goal is to design an affordable version of flexible potentiometer that has greater consistency and less delay than the model originally designed by Lawrence Lai. Now, here's a photo and a little description of his flex sensors. They're cost efficient. They're cost efficient and they use carbon graphite as an insulator, two copper wires as a conductor, and it's encased between two acetate sheets. Now, here's the code. I'll leave that up on the screen for a few seconds. Okay, and so we compared our data to Lawrence Lie's prototype, and we found that his prototype resistance values varied by up to 80 ohms and 80,000 ohms in one singular spot, and it had a delay of 1,000, which encoding is equal to 1 second, which is pretty high. And for ours, the resistance only tended to vary up to 20,000 ohms. So it was a lot more consistent. And then our delay was only 60, which is extremely faster. Now, here's a few images. Over to the left, there's our wiring for the project. Um, on the bottom, there's the wiring for Lawrence Lie's project. And then the photo to the top right is three different forms of flexible potentiometers that we created, with the rightmost being the one we used in our final model. Now, for conclusions, the prototype flexible potentiometers were a viable alternative to traditional flex sensors, as we were able to detect the bend of a hand or a limb or whatever, and transfer the information to a servo motor, and it had an increase of 300% in consistency from the Lawrence Lie prototype, and an increase of 1,567 of efficiency from the Lawrence Lie prototype. And although I have only finished the portion of the project creating a new type of flexible potentiometer, I still plan on creating an application for the new flex sensor by the time of the in-person fair. Possible applications for this technology include more complex gesture-controlled technology, which can help improve areas such as prosthetics, dangerous professions, and cost efficiency for robotics in general. And I believe that is all. Thank you for watching.